Hello everyone. In this tutorial, we are going to learn how you can implement a first-person camera in this game animation sample project with motion matching. In the previous tutorial, we learned how you can implement a custom character in this project with motion matching, and we learned how you can implement crouching and sprinting. We also learned how you can add the animation data with the animation layers with motion matching. Here it is performing the upper body attack animation, but the motion matching is still working. So now we will learn how you can implement a first person camera. So without further ado, let's get started. So let us first check the character blueprint. So this is the character blueprint sandbox character. So this is the main blueprint through which other blueprints are derived. So over here you will find that there's a spring arm and there's a camera attached to the spring arm. So you'll see the spring arm has some arm length, hence it is there, and you will find the camera was over here, the mesh is over here, and there's this control. When you press the right mouse button, when you hold it, you see the camera is zooming in or it is coming closer to our character. So let us first understand how is this happening. So let's get back to the character blueprint. Over here you will find that we have aim input. So this is right mouse button. When the right mouse button is pressed, there's this variable wants to aim. It gets true and it gets set, and when it gets set, it is zooming in, right? So if you find here in the variables, we have this camera variables, cam style, far, close, aim. So this aim variable is getting used currently. So if you quickly just set this to 0, let's see what happens. I will compile. You can directly go to save and compile on success only. So what will happen when you hit compile, it will automatically get saved if there are no errors. Alright, so now if I press the right mouse button, you see how the camera is zooming in to where I changed my target arm position of the spring arm. You see we needed something like this, right? So now we just need to add offset and few other tweaks we need to do. But if I leave the right mouse button, it's just getting back. Alright, let's see what is happening. So what we want to achieve, if we want to set the target arm length to 0, that is correct. The socket offset we need to set over here. So you see the x-axis. If you look over here in the gizmo, you'll find the x-axis is right over here. So we need that over here, socket offset. We want this to offset somewhat like 25, so that we do not see the head of the character. And also we want to set the offset in z-axis. We want this to move a bit upwards, maybe like 5 or something. Alright, so somewhat like this we want our camera to be, the spring arm. So instead of changing here, we want to change it inside this parameter value in this variables over here. So we will set the x to 30, we set the y, we do not need offset in y-axis, right? We set this to 0, and this we can set it to 5. We'll come back to these variables in a second. So let's see now what happens. I'll hit compile. We'll close this. Let's run. So if I hold the right mouse button, you see it is now transitioning from the previous camera position to my current camera position, right? We still need to move our character a bit, the camera a bit forward, but yeah, now it is not actually following the head. We will need to do that. Okay, but you understood the concept, what is happening. So let us see how it is happening now. How is this variable causing the transition? So if you want to find where it is getting used, you just right click and find reference by name. Alright, and double press on it, you will find this is being called inside this new function called as update camera. Now let's see where is this update camera getting called. So just find this function here, camera update camera, right click, find reference, find by name. Okay, here you will find, double click on it. So this is getting called in eventic, and there is this boolean over here, interpolate. Interpolate just means smoothly transition. That is interpolation, linear interpolation. There's spherical interpolation, but here I think they are just using normal linear interpolation, which is LUP. So here the interpolate set, this is set to true. So the update camera set to true over here, and here the event possessed, here they are unchecking the interpolation. Alright, so double click on this. Let us see how this is happening. So if the wants to aim variable, if it is set to true, means when I'm pressing the right mouse button, it will get true, right? So when this is true, it is selecting this parameter, right? That is what we put over here. Otherwise it will set this parameter right over here. These are the default parameters. Okay, and there's wants to strafe. We'll not look into this because we're just interested in wants to aim. So wants to aim, this is the parameter, right? That means that is selected. All right, then we are breaking the parameter, this same parameter we are breaking. All right, it's returning the value, it is breaking. And what is happening over here, this interpolate, if it is true or false. Okay, and here they are storing camera distance and everything, and over here target, and it is stored to target camera parameters. So here's where the target is stored. Okay, according to whether you want to aim. If you want to aim, this is the one which is getting selected, and that is getting stored in the target camera parameters. All right, now from here the transitionings are happening. You will find that here finterp2, this is the function which is used for interpolating from one position to other position smoothly. Tries, if you just hover, you will find tries to reach a target based on distance from current position, giving a nice smooth feeling, right? So over here you'll find a current camera position. So here I think we are setting the field of view. So the camera's field of view, so the current field of view and the target field of view in the given time and with given some speed, it is interpolating. Hence the field of view is smooth. Let's see what's next. Target arm length. The arm length is changing, and that is smooth as well. How is it smooth? So the current arm length is stored over here. We are giving the target arm length, like here we save the target, right? So the target arm length, and that is being interpolated. Next, the spring arm camera lag speed, right? So what is this camera lag speed? Controls how quickly camera reaches the target position. Lower values are slower, means more lag. Higher values are faster, while 0 is instant, no lag. All right, we'll look into this as well. We'll understand this by doing it practically. Okay, here also the spring arm interpolating with the current camera lag speed and the target camera lag speed, interpolating the same. And finally there's this socket offset that we are giving, right? So the current socket offset to the target socket offset. So this is our target, right? Target socket offset, and the current which is close, this one. So it will interpolate between these. So that is how it is smoothly transitioning. All right, so now I'll save this, we'll close this. Now let us check. I'll hit play. So if I hold the right mouse button, see, it is smoothly transitioning right over here. So that is how it is working. Now let us add few things so that we get a better first person view. So what we need to do is, this spring arm is having no reference with the mesh currently, but we want so that it is controlling the head's position, right? So this spring arm will be the child of mesh now, and we want that this spring arm or the camera, right? We want the camera to be controlled by the head of the character. Okay, so the spring arm, how it is possible? Using this parent socket. So I will search head. So these are the bones of the character. Because we put that inside of the mesh, we drag and drop inside of the mesh, we will find these bones. So I'll search head. So with this, what will happen is wherever the head position is, the bone, the head position or the rotation is, accordingly the camera will change. Accordingly any child will change. Okay, because we have added the parent socket. It will copy the location of the head and it will paste it inside this spring arm. Okay, so now you see that we have some offset. So we'll just quickly reset these offset. We don't need. Okay, so we just reset the offset. I hit compile. All right, and now let us hit play and see what happens. Okay, I'll hold the right mouse button. Now you find it is better than before, right? You can see the legs, you can see the hands, but we can still see the head, right? So here is where you will play with the values, okay, and you will find a value so that you don't see the head of the character. And likewise, let us switch to the default character here. Okay, I'll press the right mouse button. So yeah, here is where you will play with the values. So let us see right over here. But before this, let us what we can do is, currently we need to hold the right mouse button. So let us fix that. Let us fix where you press a button and you switch to the first person camera and switch back if you press it again. So for that, let's go to the input folder, content. There's this input folder. Let us create a new input action. We call it IA underscore first person. Over here, the triggers, we set it to pressed. So when you press it, this will get trigger. Okay, and inside the mapping over here, just add one mapping. Okay, I've already added that before. So this will come up. So input action FP, and open this up so that you can assign a button to it. So you can assign any button which is not currently being used. So I just use Q keyboard, this one. And if you want to add a controller input as well, you can quickly click over here and not the mouse. You can select the gamepad and here you can add a controller input for the same. Alright, now save this. Now we will use input action first person to control to switch to the first person camera. I mean, it is the same camera, but yeah, you will zoom in and zoom out. So right click, input action first person. So this will get triggered. I want it to do flip flop. So when I press the button, firstly A will get executed. When you press the button again, B will get executed. You press it again, A will get executed, and then B. So this is how the flip flop will work. Alternates between A and B outputs, starting with A as it said. So we wants to aim to set it to true when I press A. In the A section. So over here in the variable, just search wants to aim. There's this variable. So short trick, you hold the left alt key, drag and drop this. It will automatically set the variable. You hold the left control key, drag and drop. You can get the variable. Alright, here we just want to set it. So I'll set it to true. And here I will set it to false. Alright, now hit compile. It will automatically save it. So I'll press play. Now if I press Q button, you see how it switched to this parameter of this aim, right? Now it is switched back smoothly. Alright, so now that we have the we have sorted switching back and forth over here, let us add few more things to this to make it look a bit more first person look. Go to the camera, the blueprints over here. Inside here, the camera. So there's this camera setting called as use pawn control rotation. So what this means is we are telling the camera to use the pawn, this character's rotation. Okay, but what I want is I have already added the head as a parent socket, and I want the head to control the camera. Okay, I mean our mouse will also control, but I mainly want that the head will control the camera's rotation. So I don't want use pawn control rotation when I'm in first person mode, right? If I uncheck this, you will see where is this camera got into. So you need to change this to 90, the rotation actually, and here we need to set it to -90. Okay, so now wherever the head is actually looking, before we were just making it as a child of head. Okay, now we are totally getting everything from the head bone. Okay, we are not using use pawn control rotation. What happens is in the pawn control rotation, wherever the pawn is rotated to, there is where the camera is rotated. So we will uncheck this when we are inside the first person view. Okay, you now drag and drop the spring arm and set control use pawn control rotation. I set this to false over here, hit Ctrl D to duplicate, get it, and set this to true over here. Alright, so according to me, I think this looks much more better than before. Now I will just press F11. Okay, press Q again. Oh, there you go. Now I'll just leave my mouse. You see how the head animation is getting played, and I think this looks much more realistic and amazing. And you can still control your camera with the mouse. Okay, so here I start. I press crouch as well. You see it will automatically crouch here, and I can control. Sometimes the head animation doesn't let you control, but I think that looks fine. Okay, now you will also see when I'm doing parkour, you see how this is getting the head rotation, adding it to the camera. Okay, now we need to fix the location of this camera so that it looks much better, right? So get back over here. Also, what you could do is you are the head of the character is visible, right? So I thought maybe we can hide the head of the character, but what happens is after you hide the head of the character, then you are unfortunately not able to get the animation from the head. So there's this function called as hide bone by name, right? And here you just need to put the bone name, which is head. The H is small, right? If you hide this and if you unhide this when you are not in the first person mode, what happens is we are correctly getting everything from the head bone. But when the head bone is disappeared, it is hidden, then it won't get the. So if I press Q, you see how the head disappeared, but we are not getting the those realistic kind of looking animations of the head from where the camera was controlled, right? If I press Q again, the head comes back. So yeah, so instead of this, we will need to play with the values. Okay, I'll hit compile. Okay, so now you need to play with these values. We learned that the transition lag speed was something how fast the camera will catch up to the character, right? The more the value, I think the more the. So if we head back over here, camera lag speed. Hover over this, you see, if it is it controls how quickly camera reaches the target position. Lower value means slower, faster values less lag, and while 0 is an instant. So let us set this to 0. means no lag according to them. Let's see what happens now. So press Q now. So I think there was a bit of lag where our character moved away from us, right? And I don't think that's ideal. It switches back automatically after few seconds. I think if you do something like this, yeah. So I don't think we will stick around to 0. I don't think so. If it is less value, then that means more lag, means the camera will still be behind. If the value is increased, what happens is that the camera is moving forward. It is going faster than the mesh. We also don't need that. So I thought that 15 is a better point over here. So let's stick to 15. We'll play with this as well. You can increase the FOV. Okay, so I'll set this to maybe 110. Okay, let's see how this looks. Press Q, press F11 to full screen. So we can see the legs and the hands, and I think this looks nice. This looks nice. So you can stick with this, or you can play with the values more, and you can find your character's value over here, right? So I think I would stick with this, but still you can play the values, move the socket and everything, but this looks nice. Okay, so if I head back over here, you can try this with the other character as well. You can see it looks nice. See with the Wukong character, see when it is possessing and unpossessing, the wants to aim, that makes it false, I guess. Okay, so this looks nice. I would stick with this value. I might move in my custom character, I might move a bit forward. So yeah, so that is how you can implement this first person camera to your characters, right? So right there, I can increase the FOV if I need. I can also increase this. Also, you can increase the height of the camera if needed. This looks nice as well. Alright, so next what we would implement is, let us add a vignette and a fisheye effect to the camera so that it looks a bit more realistic kind of, right? So let's try to add those. You could try to increase FOV and play with those values. Alright, now we will implement those materials, post-processing materials. Let us go to the content folder and we'll create a materials folder. And we'll create another folder of post-process material. And here let us create two materials. So one will be material vignette, and the other material will be fisheye, right? Let's quickly open up the vignette material and let's implement that. So I'll explain you how we can implement this vignette material and the fisheye material for the post process. So over here, select this output node, and here material domain, we need to set it for post processing. Alright, so over here what we will be needing is, first will be just add a simple color or the tint you want for your vignette. So I'll select a constant vector 3, which is the color. So this is a basic color. If I just quickly set it to any color over here and attach it, you will see on the screen that color will show up. Okay, so I would like a simple grayish color over here. I'll make it more dark. This seems fine. And so we want to apply this in the material. So I'll apply this. I'll show you how you can add it to your camera. So go to the content where we have the blueprint here. Go to the camera. You just select, just search for material. You will find this post processing material. By default, it will be empty. Click on this button to add an asset reference, which is Vignette. Alright, I'll hit compile, and that's it. Now you will be able to see the post processing material through your camera. So save it, and I'll show you. Now you will see, as our post processing material was just this gray color, hence we are looking at this gray color. That's it. So now we'll work on it. So go to content, where is this material, vignette. Okay, so what do we need is, we need first the scene texture, which is the texture from the scene itself. Okay, and not the color, the post processing input. Okay, and as this is vector 4 actually, okay, this has 4 vectors, RGBA, and here we have just RGB, and we want to add both of those, actually basically just add. So here what we'll do is mask, so that mask this component, so that we are just using these 3 variables RGB. Okay, and then we want to do is LERP, linear interpolation, and so there are multiple methods to implement this. This is one of the method. If I set this to, I'll just connect it over here. Okay, if I set this to 0, so that means it is normal scene texture what we are seeing. If I set this to 1, which is this, if I set this to 0.5, this alpha value, that means this is the middle value. Okay, so if you play, you will have a look that we have this tint over here. So the scene texture, we are capturing the scene, right? Okay, so what we need to do now is play with this alpha value, so that we have a spherical, so we will be using a sphere mask. Okay, we want to mask, use if you know how the vignette looks, so there's the dark corners, right, and the middle is really clear. So to get the position, we will have a screen position. So right click, add a screen position. Okay, so the screen position, and we want to add a sphere mask. So we want to mask from the screen's position, right, to the middle of the screen. Okay, so we will just hit scalar parameter. Well, not actually, just need a constant over here. Let's set this to 0.5, so that we are in the middle of the screen, and we will add scalar parameter, call this radius. Okay, and another one, this shortcut, you hold one button, one key, and you'll find you can right click, convert to the parameter. So one, the hardness, right click, convert it to a parameter. Okay, so hardness, we'll give this some radius, maybe 0.5. Let's keep all of them 0.5. Okay, now we will add the sphere mask to the alpha. Let's see what happens. So hit compile. You see what is happening. There is this vignette kind of thing happening over here. If I set the B to 0, you see it is in the left corner. If I set it to 1, it is in the bottom right corner. So hence, if set to 0.5, it is in the center. Let's see what happens. So this dark circle is in the middle actually. We actually want it much more darker. Okay. So press play. See this, the dark circle is in the middle. We want to invert this. We want it to be in the corners. The darkness will be in the corners, not in the center. So simple fix. You will invert this mask. How to invert? You just press 1 minus X. It will negate this. Now it will be in the corners only. Alright. So go ahead, save. I don't know what happened to my preview. Not able to preview this actually over here. Okay, save this, and now play. You get this good vignette. Now you just have to play with the values, the parameters over here, right? You can create a material instance and play with the values over there, but yeah, I'll put the 0.65, and the hardness is how sharp is this, right? And let's have a look. Somewhat like this, you get the effect if you're in the first person. And now you will see if I add the fisheye effect, it will look more nice. So let us create a fisheye effect now. So we'll open up fisheye material. Okay, so here first what we will be needing. So in the previous one, what we used is we got the scene texture and we added a mask over it according to its position. Here what we are doing is we are actually distorting what we are looking at. Okay, so first we need the scene texture so that we can have a look. Scene texture, of course, post process input 0, attach it over here. Now we will play with the UV to distort the scene texture itself. Okay, we are distorting that. So over here, let me just quickly show you what happens if you play with the UV over here. You just quick texture coordinate, and here you can actually tile. So if I set this to 0, 0, or if I set to 0.5, 0.5, you see how it is tiling this. Set it to 10 and 10, it will tile accordingly. 2, 2. So this is what this scene texture UV does, right? So we want to distort it from the center, right? So again, we need the center. So how we can get it? Get the screen position first. Okay, and through the screen position, what we did over here, we use a screen sphere mask, and from here we got the center, right? Here for distorting, for adding a fisheye effect, we will use something called as radial gradient exponential. So radial gradient exponential, and here you need to put a center position. So center position 0.5, right? So default value is 0.5 of course, but you can just put it 0.5 over here. Okay, and we need to add a radius, we need to add density in here, and of course you can convert it into a parameter, radius, and this as well, density. Okay, we set it to 1.5. we can change it afterwards. We set this to 1. Alright, so we have this now. What if we directly connect it over here? Let's see what happens. See, it is some weird kind of thing is happening. Okay, so it is doing the fisheye effect, but it is really mixed up right now. Okay, you can change the value here, like 0.1, if I do to minus 0.5, and 0 does nothing. So yeah, you need to play with the values now. So what we will do is, firstly, let us understand what we need to do. We need to subtract the current camera position to the radial camera position so that we get this fisheye kind of effect. So from here we will subtract. If we directly do this, subtract this from this, we get something, but we need to do it from the center, right? Even though we have added the center over here, we are not currently getting the center. So 0.5, set this to 1, even minus 0.5, I think. Yeah, still this is not the center, so we actually need to get the center over here. So let us add some intensity also we can add. So let us multiply, just add this multiply sign from the keyboard, and let us add one parameter over here. We call this as intensity. Okay, by default set it to 1, and you can increase or decrease the fisheye effect from here, right? Okay, so now we need to add some offsets over here so that we can get to the center. So from here we will first find the center. Okay, so we will subtract 0.5, we'll get to the center of the UV, I suppose. So this is some kind of offset, and we'll multiply this. So just do the multiply sign with this. Okay, and I guess we can multiply this directly, and we are good to go. So this is how is this fisheye effect. You see, I can increase the intensity of this from here, add it to 2, right? Can keep it 1 or increase the intensity of this, right? I can increase the density of this. Well, 5 was much more, right? So now you can play with the values. Okay, so from here what we did, so this is the main screen position, we subtracted 0.5 from its UV, right? Here we were getting the center position. Okay, so this is the distorted node. Okay, we subtracted from this center, and this is also from the center. We multiplied this, okay, and we multiplied with the intensity, and we finally subtracted this from this. If we directly add it over here, you see there's nothing over here. What if we, instead of subtracting, what if we multiply? So let's see. If we multiply this with this and add it over here, so yeah, we do not need that. Okay, we subtracted that position to this position, we put it in the UV over here, because at the end we need to calculate the UV, we are not multiplying anything. Okay, so now you just add this fisheye effect inside the camera. So go to the content, here the camera, material, we add another material, asset reference, fisheye. All right, and here you can set your final values. You can set it 45, and this might work. I can set the transition speed as well if I want it to go much slower. Okay, Now you will find the fisheye effect right over here. I think it is much more wider over here. Press Q. So I can decrease the fisheye effect over here because it is much more vast in here. I think set it to 1 default. It's also fine. I can decrease the intensity of that, and over here we can increase the field of view, maybe 100. Okay, let's hit play. So it is kind of first person view. Right. So that is how you can implement this fisheye effect and all. You can decrease the intensity through here. And this also looks nice. So yeah, that is how you can implement this first person camera with this motion matching with these effects. And suppose you do not want the effects when you are in third person mode. So I think what you can do over here, just shift this here, you get the camera. So we can set the post process blend weight. Let us check. If I set this to 1 over here, if I set this to 0 over here, I suppose this should work. Okay, so there must be some other way to disable this in this third person mode. So instead of this, we can set post process blend weight. What is in the settings? Let's see. Okay, we just set the post process blend weight. We set this to 1 when we want it to enable, and set it to 0 when we do not want. And at the start, let us disable that. We'll set it to 0. The camera pushes material right here. Set this to 0. And let's check now. Play. I think this will remain 1 over here. At the start, we can set it to 0. Yeah, even begin play. So right click, begin play. At the start, we will set it to 0. I think this would work. Press Q, now it is visible. Press Q again, it is not visible. So yeah, this was how you can implement even with the custom characters. That would work. Yep. So press F11. So that is how you can implement the first person camera with motion matching custom characters. So I'll add this to the playlist as well. You can view the previous tutorials on how you can add the custom characters, how you can do the crouching, sprinting and everything else. I'll add this to the playlist as well, and let me know what else would you like to see with the motion matching. And thank you so much for watching this tutorial, staying here with me, and please provide your valuable feedback, and we'll see you in future tutorials. Thank you.